dealt with multiplying. What did we deal with after that? Dividing. But isn't it normally when you're doing these kind of chapters, don't you deal with adding and subtracting, then multiplying and dividing? Do you know why it's reversed in this chapter? Because adding and subtracting is tougher.
What?
It's tougher.
It's really the other way around.
It usually, yes, like you guys probably already noticed in your own experience, it's usually the other way around. I'm going to add a little bit of geometry here. I want you to draw just a little line segment, and you're going to label it, excuse me, AC. So it's a segment. That means it has a starting point and an ending point. And then there's also another point in here, point B. So I got point A all the way to point C, with point B being in the middle.
Is this supposed to be in the middle?
Oh, no, sorry. Okay, hold on. It is in the middle. It's not directly centered, but it is in the middle, right? I mean, that's what you say. No, don't make it centered because it's not. It's not really. So yeah, put it where it looks like here. And I'm going to give you a couple measurements. We're going to say AB's length is 3 over 2x. And there's centimeters. 3 over 2x centimeters. And then we're going to call BC's length 7 over 2x centimeters. So those are those two lengths. All right, this is back to geometry. I'm going to throw out something there because I want you guys to be ready for it when you get next year. It's called segment addition postulate. Okay, postulate is just something that's been proven to be true. Okay, here's the postulate. Ready, guys? It's very deep. Segment AB plus segment BC equals segment AC. Do you guys believe that? Is that true? Mm-hmm. So when you see it next year, for a lot of you, you're going to be like, segment addition, what is all that? It just means that when you have an entire segment and you have a point somewhere in the middle, somewhere in between those 2 points, that this little segment plus this other segment is going to be the whole segment. How do I find the measure of segment AC? Add the two. I have to add these two values. Do you agree with that if I'm trying to find AC? All right, good. So here's my addition problem. 3 over 2x plus 7 over 2x. All right, when you're adding fractions, what must be true before you start combining things? Common denominators. They have to be the same. So looking at these two rational expressions, do they have a common denominator? Yes, it's 2x. So what do you add? The numerators. So 3 plus 7? 10 over 2x. But it can be simplified, right? Yeah, reduced. Yep, simplified or reduced.
Even though it's 2x, can it still be reduced?
Yeah, remember, why can I do this? So this is what some of you are thinking. I thought you can't do that if you have the 2x there. But what's happening between the 2 and the x?
They're being multiplied.
They're being multiplied, so I can undo that by dividing. Okay, good. That's a good question. So I get 5 over x. That is our length of the entire segment. Okay? Now, before I move on this problem here, x can be any number in the entire world, except for one value.
0.
X cannot equal 0. And somebody explain why it can't be 0. Yeah. What can this denominator not be worth? 0. And that denominator cannot be worth 0. So if you made x equal 0, what's 2 times 0? 0. I don't want that. So don't forget excluded values on these problems. The return of the excluded value. Okay. Any questions on this? Okay, let's move on to another problem. Let's draw another line segment, and you're going to label it XZ. So XZ, and put another point here, Y, and it could be a little closer to C, and it's in the middle. Not directly centered, but it is in the middle. And let's get some values here. Okay, the length of X z. So I'm drawing this right here to show that this is the length of xz is going to be 7a squared over 4a. And it's inches in this problem.
Do you want us to draw the line?
Yeah, draw this line, this other measuring line. This is not this is not the segment we're talking about, but we're just saying that length is that much. And then the length of xy, so the length of xy is going to be 5a squared over 4a. What do you think I want to find in this problem?
You want to find out what y is.
Yeah, what's the length of yz? So I know that xy plus yz is going to get me xz. So how do I find this problem out? How do I find that part out? Yeah, you can think of it, and really the lesson's called, what is it called? Combining or combine? What does it mean to combine?
I'm asking.
Yeah, rational experiment. What does it mean to combine?
You bring
Add. You bring things together. You're usually adding things. But this problem is not adding, which is also known as
Adding negative.
good. Adding the opposite, we would say. Yeah, adding the opposite, which is combining. You're combining things. All right, can you combine these two just like they are? You can because you have common. Good. So what's 7a squared minus 5a squared? I think it's 2a squared because you're subtracting over 4a. And then what can cancel out, Davis? 2 and 4. And a and a.
Wait, so we don't have an excluding factor?
Hold on. Let me write this answer down. A over 2. Okay, a over 2. Were there any excluded values?
No.
0. Right?
Well, remember,
It's always going to be 0.
sorry, let me get this. Excluded values are always going to be a variable cannot equal something. So what's that something?
No, it's nothing. Nothing. You don't have any. Because a will be 0. Yes, they can.
Remember, the excluded value comes from the original problem. I think you guys are looking at this and saying there's no excluded value. You're right, there's no excluded value here, but isn't there excluded value up here? Always go back to the original problem to get excluded values. Yes, ma'am. Is it always going to be a or 0?
Yeah.
No. Why is it 0 on this problem? Because it's just multiplying and the
Because the denominator.
denominator can't be 0. Yeah, I don't care about what's in the numerator for excluded values, just down here and down here, which are the same, thankfully. Let me get Nick. Can you wait a little bit? Or sorry, Nick. Yes, ma'am.
So wait, why is it 0? Like sometimes it can be 0.
Yeah, because what you have to do is replace a with some value that would make the whole thing 0. So can a be 1, for example?
Yeah.
Yeah, because what's 4 times 1? 4. So that's allowed. But what can a not be? What's the only value it can't be down there? 0, because what's 0 times 4? 0, which makes that whole thing equal 0. So here's how I could figure it out mathematically. I say 4a cannot equal 0. So solve for a. So you divide by 4. And what do you get? A does not equal 0. That's how you figure it out. If you didn't know it right away. Next problem. Yes.
Okay, so like, when we were just saying that, we said a cannot equal 0. So if you have like a binomial or something, and you just trying to get it where the denominator never equals 0. So if it like wasn't like 5, like it just a 5x squared, and you were multiplying, then if it was like,
A binomial?
yeah, then you just make sure it doesn't equal 0.
Yeah, and we're going to get those on the next set of problems. But these problems, this one, the next one, all the variable cannot equal 0. But yes, if you get a binomial down there, it could change that value. All right, so can I add these two together, Matt? Okay. Okay, you technically could simplify like this one, but what do you have to have when you're adding fractions? You have to have a common. So do I have that right now? Good. So I could add just the way I have it here. Emma Grace, I have common denominators. So what do I add? So what do I get? Michael.
4x squared over 5x.
Close. It's really 1x plus 4x, 5x. If you were multiplying, your answer would be nice. 5x squared. All right, but is that simplified, Wyatt?
No.
What do I do to get it simplified?
Cross.
Okay, I get 5's out, 1 and 1. X is out. So I'm left with
1 over.
1 over x. And were there any excluded values? How many should I have, by the way?
You should have 2.
2. But what are they both?
0 and the square root of 0.
You say plus or minus the square root of 0.
Yes.
Because 5x squared, here's how you're finding it, cannot equal 0. Do you guys agree with that statement?
I agree with that.
So how do you find out what x can't be? You divide both sides by 5. You get x squared cannot equal 0. You square root both sides. Remember how many answers you technically get? Plus or minus 0, 2. So x cannot equal 0, whether positive or negative. Okay. Look on page 314. Did you guys see example number 2 where it says subtract in that box?
Yes.
Okay, do that problem. And you have the answer right there, so hopefully it's not too bad.
I got the answer.
Just one moment, Michael. Sorry.
Sorry, what was that?
Yeah, 2 on page 314. Okay, yes, sir.
Can I go to the office, please?
Yes, you may. Okay. Jensen, can I add these just the way they are? All right, I can because Mackenzie, they have like denominators. So what do I actually combine, John?
You combine the top part, but not the bottom.
Good, the numerators. So what's 2c minus 8c? Negative 6c. And I common denominator. Please don't ever combine the numerators or don't combine the denominators when you're adding or subtracting. Don't do that. Is that my final answer, Rachel?
Oh, definitely.
Okay, what do I do? Davis.
So you guys do -6 and 3, it can be -2 and 1, and then C and C, whatever. And it's -2 over C.
-2 over C. What's another way to write this, Marissa? -2 over C, because maybe you wrote it differently.
You could do the negative in the middle of both.
So -2 over C. What's another way to write this one, Nick?
You can write it, actually,
That's okay.
2 over negative. 2 over negative C.
Yes?
or -2 over C.
2 over negative 6.
2 over -C. Do you guys agree with that? Do you agree that any one of those answers is correct? Okay. And listen, if you understand that, that's going to help you out a lot when you don't want to deal with a negative denominator. I want the opposite of that denominator. Some of you are listening. You're looking at me. You're not even listening. I could tell. I have 2 boys who do it to me all the time. And I used to do it all the time. So I get it. Okay.
So I'm going to become math teacher. 'Cause it's not.
That'd be cool. Okay. Anyway, perfect.
Were you ever
Yes, ma'am.
will you ever have a time where the denominator isn't the same?
Yes. But thankfully
Like, what
today's...
will you do?
Yes, okay. First, thankfully that's 12-6,
Oh, okay.
which is nice. That's tomorrow. But if you do, you got to make them the same.
I don't
So we're going to figure out how
I
to
mean,
do
like,
that.
do will be today?
You find
Here's where we're going to get a variety here. Okay, how many of you are doing okay so far? You're like, okay, I got this. I got this. Good.
Yeah, you can just hand us the homework. We'll be
Really, I want you to do this problem first. And I'm going to allow you to work with somebody next to you. Don't get up, just work with somebody next to you. This problem right here.
You do it with the partner?
Yeah, you can. You don't have to. Around you without getting up. Yep, you can go front, back, diagonally,
I will win.
but don't get up, don't scoot.
I don't think we have to back. Oh, wait. don't think we do. I think it's
What?
It has the same denominators, so we just like subtract.
All right, I'm gonna give you a hint before I get to that. Before I let you guys get too far.
No, Mr. We don't need him. We don't need him.
Oh, I'm gonna give it. 'Cause some of you do need it. All right, they have common denominators, so I could subtract. But remember, it's this minus that.
So
What?
you can't. So right, you don't. You have to cancel. Like you do 7h minus 2h first. You do 7h. You cancel out. Can you answer questions?
Pretend I'm clueless. Is that Murphy?
That's right. How do you do that?
Wait, what class are we in?
Math class.
I'm supposed to be on my free hour right now. No, man. Wait, what's going on? Why are you guys here?
Away from you.
I'm not speaking in Spanish. Okay. All right, here I'm gonna. Can I help you out here? Okay. Listen to me carefully. Do you really understand stay, change, opposite?
Yeah.
Okay.
That's what it's division.
Oh no, you're thinking stay, change,
The
flip.
opposite is terrible. You
Okay.
don't do that. You subtract. Subtracting is amazing.
All right, ready?
Oh no, we kind of messed up. So
Stay,
it's actually positive.
change. What's the opposite of this?
No.
2 plus 2h.
Now go. Yeah, you don't remember. You don't add or subtract the denominators. You're just dealing with the numerator.
Oh wait, you added negatives.
I'm guessing most of you were okay with the 7h minus 2h. You got that. But you put negative 2h squared, which is not the case. It's positive 2h
That's what I
squared.
just said. That's what I got.
Stay, change, opposite. That's one way to do it. You can do it other ways, but okay. Now look at the numerator. Are there any like terms in the numerator? Yeah, the 7h and the negative 2h, which gives me 5h. Good. And I'm going to write in standard form, so I'm going to put 2h squared plus 5h minus 3 all over 2h minus 1. Is that simplified? You're going to have to factor sometimes. All right, so go ahead. So, but you got to factor it now.
I got that numerator though, and I didn't stay change opposite.
That's okay. I'm good with that. Just be careful with that.
You cross stuff out.
No. Yeah, so you're going to have to do your bridge.
I feel like I should be getting this.
No, if you don't, just do the bridge, and I'll do the bridge up here. So you got to get negative 6, and you got to add up to get 5.
So yeah,
Okay,
you just-
there are other ways, good.
Yeah.
Hey guys, remember you do have homework, and you have more time than the other class, but I don't know if you'll get time. Okay, you guys have these right here, so you're going to rewrite it 2h squared, and then, bless you, plus 6h minus 1h minus 3. Factor that. Factor by grouping. You got your 2h times h plus 3. What's the GCF of these two? Negative 1. And I'm left with h plus 3. Listen to me right now. You need to understand what this is right here. Negative 1h minus 3 is also known as negative 1 times positive h times, positive h plus 3. This is the same as that. I'm telling you right now, you need to understand that because I'm going to require it on a future problem.
Will any of this help us in geometry?
No.
Yeah, it's going to get you h plus 3 times 2h minus 1. Thank you.
Wait, Mr. Ray, will this work? Will this help us in geometry?
Yes, factoring.
Yeah, but wouldn't it be wiser to take algebra 2 first and then you?
So honestly, when I was growing up, we had algebra 1, algebra 2, geometry, yes. But they switched it up. Geometry uses like algebra 1.5. It's just like kind of more, but it's in the middle. So that's why they do
I
it,
don't
which
like
is fine.
shape.
Oh, you do like shapes. You actually love them.
I hate shapes.
No, you actually like them.
No, I don't like shapes. My
Doubt
hand's
it.
not a shape.
What's one thing you like?
What's one thing I
One
like?
thing.
Candy.
Shapes, good. And next, sorry?
Water.
Shapes.
No.
No, water. You know that water in its atomic form is a shape?
It's gas.
It can be gas, yeah. But the H2O molecule, it is a shape. It's like, it's a it's like a, I don't know what to call it. Ask Mr. Hubbard on that. It's gonna be a shape, and it's a beautiful shape, and it's all
Mr. Ray, I like
over.
this. This is not a shape. Mr. Ray, I like letters, and those are not shapes. They don't enclose.
I use the John.
All right. What cancels out here? And you're left with? H plus 3, that's your simplified form. Some of you aren't going to get this, and I kind of feel bad, but I can't feel too bad if you're goofing off in class. Okay, Nick, before I answer that question, I need to ask Alyssa, were there any excluded values?
John Hack.
Okay. Sarah, what is it?
Negative, or just positive 1/2, sorry.
Positive. H cannot equal positive 1/2. Yes, sir.
So can you, so you see when you get your little bridge thing? Can you just simplify from there, or no? Because I tried to.
Addition and subtraction.
Yeah, you're like blocked by those two things, and it would make it, yeah, you would cancel that out and mess it up. Or even the H's, yeah. Yes?
Couldn't H minus, or H cannot equal negative 3? Couldn't that be another excluded value?
H cannot equal, oh, I think you're thinking the numerator. The numerator could equal 0, so H could equal negative 3, but let's check it. What's 2 times negative 3? Negative 6, minus 1, negative 7. You're okay with that. The denominator gives me excluded values.
I thought you looked at, like, never mind.
That's okay. All right. That one's a little more involved, and this is the last type of problem I'm giving to you.
That's right, I'm really excited for this.
I am too. Wait. Yeah, sorry, okay.
No, you're.
This is the last. Let me make sure. Hold on. No, okay. I think I skipped one, but that's fine. I'll give you this one. All right, 4K. This is basically example number 2 on page 315. So 4K plus 7 all over 3K minus 6 minus 3K plus 9 over 6 minus 3K. So this is like a transition to the next lesson. But we're not going to get to the next lesson, but you need to be ready for the next lesson. Okay. Do we have common denominators?
Don't be like that, Mr. Ray.
Can you make it?
Ooh. Tough question. All right. Time out. That's okay. I do that all the time. And so does Titus. Okay, go ahead.
We do not have common denominators.
Can you like switch it and make it like negative 6 plus 3?
You don't
You
have
can. How?
Associated.
Okay, I asked you guys a question if you understood that this right here equals this. You guys said, yes, I agree. Yeah, so I hope, let's see. Ready, guys? I'm going to change this right here. Please look at it because I don't want you to get confused. I'm going to factor out a negative 1 and put negative 6 plus 3K. You tell me if that's right or wrong. So I'm canceling that out.
But the problem is, it's right, but would it change the answer?
Switch the negative.
All right, look at my two denominators. Look at my two denominators. Look, do I have a negative 6 now? Yep. Do I have a positive 3K? But that negative 1 doesn't just disappear. I have a negative in the denominator, right? The negative in the denominator. And I have a negative outside the fraction. So what do I technically have?
A positive fraction.
Okay, ready, guys? Ready? Two negatives make a... Dun, dun, dun. It is cool. It really is cool.
Mr. Ray, I somehow got around that for
Awesome.
doing something.
John
I just
Hack.
kept on doing the problem. And it's just... Well, I just did, instead of putting the
Congratulations.
right side on the denominator, I put the left side. Does it really matter? if I put 1 times negative 6 plus 3k, like in the denominator form.
You mean you switch that?
Meaning like putting that in the denominator. Like would it mess you up in simplifying?
Can I keep working and then we'll see what we got? Okay, hold on. Do we have a common denominator? Yeah, we have a negative 6 and a positive 3k. We're good. Now I can just add the numerator. So what do we get up in the numerator? 7k plus 16 over, and we usually write in standard form, 3k minus 6. And that was the denominator. You could have technically wrote it negative 6 plus 3k. Is there anything to simplify? No. So that's my final simplification. What's my excluded value? K cannot equal.
6 thirds. K cannot equal 6 thirds.
Yep. 2.
Oh yeah.
That's okay. No. 6 thirds is correct. And then we just simplify that. It's K cannot equal positive 2. That's the hardest one you can ever get on this lesson. Yes.
So I did it where
Awesome.
I didn't change the 2 negatives. So instead of using the right side denominator, I used the left. So I put 3k minus 6 on the bottom. And then I did 4k minus 3k on the top, and then 7 minus 9. So I got like k minus 2.
What? Yeah. So see, you can't do that because we get this. We get
But I
not.
thought negative 1 in parentheses negative 6 plus 3k is the same thing as 3k minus 6.
Technically, what you could have done, this was left alone. Then you didn't mess with that. You could have done this, like we did, but that's the only other option I really have on that. Yeah. So be careful with that. All right, homework. And you have time. 2 through 8, even.
3.
Awesome. 311. 312. I want the simplified versions and the excluded values.
How much?
Great question. Let me pause. Bye-bye.